Are we on the verge of a groundbreaking discovery in our quest for extraterrestrial life? NASA's latest innovation, the snake-like robot known as EELS, short for Exobiology Extant Life Surveyor, might revolutionize space exploration by testing the icy depths of Saturn's moon, Enceladus. With its self-propelled and autonomous capabilities, EELS can navigate treacherous terrains, from steep cliffs to narrow crevices within glaciers. This technological marvel, developed by NASA's Jet Propulsion Laboratory, holds the key to unlocking the mysteries hidden beneath Enceladus's icy shell. Join us as we delve into the remarkable journey of EELS, a robot destined to venture where no human has gone before, and uncover the thrilling potential for life beyond Earth's boundaries. NASA is currently testing a snake-like robot in hopes that it could one day look for life on Saturn's icy moon, Enceladus. Developed by NASA's Jet Propulsion Laboratory, JPL, the 220-pound and 13-foot-long machine is called EELS, or the Exobiology Extant Life Surveyor, and it's designed to be self-propelled and autonomous, according to a statement from the agency. While the robot is still undergoing testing and development, engineers hope it will soon independently slither through a variety of planetary and lunar terrains. From undulating sand and ice to steep cliffs, gaping craters, underground lava tubes, and even narrow spaces within glaciers, EELS is meant to be flexible. Once it's built, if it all goes according to plan, it will be able to get anywhere, go through anything, and find any signs of life that might be on the way. That's a pretty big deal, especially on Enceladus. While there's a lot more talk about finding life on Mars and recently on Venus, many astronomers will tell you that one of the best chances we have at finding life somewhere else in our solar system is on Enceladus. On the surface, it doesn't look like much, just a big hunk of ice. But it's what's underneath that counts. Because under the surface, Enceladus is a water world. Data from the Cassini mission showed researchers that the entirety of the moon is covered in liquid water, right under the surface. It constantly spews out through cracks in that crust, sending plumes of vapor, gas, and debris out in huge plumes, some of which forms one of Saturn's rings. And when Cassini sampled that ring, it found a substance called silica nanograins. According to a NASA website, silica nanograins are only created when liquid water and rock interact at temperatures above 90 degrees Celsius, about 200 degrees Fahrenheit. This points to hydrothermal vents deep beneath Enceladus's icy shell, not unlike the hydrothermal vents that dot the ocean floor here on Earth. This means that not only is Enceladus fascinating, but even though it's far away from the warmth of the sun, its vast underground ocean is theoretically habitable. In its latest form, which is called EELS 1.0, the robot weighs around 100 kilograms and is 4 meters long. It's made of 10 identical segments that rotate using screw threads for traction, grip, and propulsion. The autonomous operation of the robot is crucial because of the long-time communications lag time between Earth and other planets and celestial bodies in deep space. A radio signal to Saturn, for instance, could take around 83 minutes to travel in one direction. It has the capability to go to locations where other robots can't go, though some robots are better at one particular type of terrain or other. The idea for EELS is the ability to do it all. Matthew Robinson, EELS project manager, says in the statement, "When you're going places where you don't know what you'll find, you'll want to send a versatile, risk-aware robot that's prepared for uncertainty and can make decisions on its own." Since the robot's first prototype was introduced in 2019, engineers have trialed and revised their design continuously. They tested the robot in a variety of environments, from JPL's own simulated Martian landscape, called the Mars Yard, to the snowy mountains of Southern California. JPL engineers hope the robot can eventually solve problems without human input. Due to time lags in communication between us and Enceladus, EELS needs to calculate risk, move around, and collect data without the help of a team on Earth. Using stereo cameras and LiDAR, the robot can create a 3D map of its surroundings to understand its environment before navigating through it. In its final form, the robot will contain 48 actuators, essentially little motors, that give it the flexibility to assume multiple configurations but add complexity for both the hardware and software teams. We can compare the actuators to 48 steering wheels. Many of them have built-in force-torque sensing, working like a kind of skin, so EELS can feel how much force it's exerting on terrain. That helps it to move vertically in narrow chutes, with uneven surfaces, configuring itself to push against opposing walls at the same time like a rock climber. Last year, the EELS team got to experience those kinds of challenging spaces when they lowered the robot's perception head, the segment with the cameras and LiDAR, into a vertical shaft called a moulin at Athabasca Glacier in the Canadian Rockies. In September, they're returning to the location, which is in many ways an analogy for icy moons in our solar system, with a version of the robot designed to test subsurface mobility. The team will drop a small sensor suite to monitor glacier chemicals and physical properties that EELS will eventually be able to deploy to remote sites. The team has likened themselves to a startup, saying their mentality is to build quickly, test often, learn, adjust, repeat. Whatever scientists ask of the robot, the engineers will try to achieve it. We have a different philosophy of robot development than traditional spacecraft, with many quick cycles of testing and correcting, Hiro Ono, EELS principal investigator, says in the statement. There are dozens of textbooks about how to design a four-wheel vehicle, but there is no textbook about how to design an autonomous snake robot. To boldly go where no robot has gone before, we have to write our own. The project's long-term destination, Enceladus, is one of our solar system's most scientifically interesting sites. When NASA's Cassini probe studied the moon, it revealed an ocean of liquid salt water below an icy crust, with cold temperature geysers that expel plumes of gas, dust, and ice. Cassini's observations suggested Enceladus could be habitable, and EELS could one day follow up on this research, investigating whether life exists on the icy world. In order to do that, it will need to be able to both slither into vents in the crust and swim through the oceans underneath, something none of our space robots have ever been able to do. And that functionality, of course, will also make the design an excellent candidate for other applications, like exploring Martian polar caps and even spelunking into crevices in ice sheets here on Earth. But Enceladus remains the main mission, and maybe someday EELS' serpentine superpowers will finally unlock one of the greatest mysteries in the universe. The team aims to finish refinements to the EELS concept by the fall of 2024, after which they hope to propose an Enceladus mission to NASA. If approved, a spacecraft carrying EELS would take roughly 12 years to reach Enceladus. Once deployed to a vent, it is hoped to take just a matter of days for the snake to reach the ocean, and the findings communicated from the moon would reach Earth within hours. The team feels they have now created a highly adaptable robot capable of exploring multiple terrains, and say that EELS could pick a safe course through a wide variety of terrain on Earth, the Moon, and far beyond, including undulating sand and ice, cliff walls, craters too steep for rovers, underground lava tubes, and labyrinth spaces within glaciers. We are early in this project, but it's achievable in our lifetime, Rachel Etheridge, EELS Deputy Project Manager, said last year. It's an ambitious collaboration, and we're motivated by the shared excitement we have for this concept and the potential science we could gather with EELS. What do you think about NASA's snake robot? Let us know in the comments down below, and remember to like, comment, and subscribe to our channel for more exciting content. And as always, hit that notification bell to stay updated with our latest videos.